Hi. In this question, a VT graph has been given and we have to draw inferences from this VT graph, as in what does this VT graph represent. So there are four options given. One is uniform motion, second is at rest, third is non-uniform motion, and fourth is moving with uniform acceleration. So let's analyze this graph. So if you see at any given time t, the value of v is not changing. So this is the value of v. Whatever is the value here remains same throughout the time. So hence v is not changing with time. So hence it is a case of uniform velocity. What is that option? So uniform velocity is also called as uniform motion. So option A is correct. Option A is correct. So this is the correct option. Now let's also analyze the other options and see what would be the case if the other options are there. So how would the velocity time graph look like? So in case of option B, that is at rest, so if you see so if this is t and this is v, so at rest, that means body is at rest, so velocity must be 0. So at rest the velocity time graph will be like that. So with time t, if you see, the velocity is 0 all the time. So this is a case of body being at rest. Now what will be a non-uniform motion? Non-uniform motion will be non-uniform motion. This could be either uniform acceleration, or it could be non-uniform acceleration. So how would a velocity time graph look like in case of a uniform acceleration? If it is a uniform acceleration, so the velocity time graph looks like this. So if it is v, this is t, so uniform acceleration will be like that. Or if there is deceleration, then it could be like that, a straight line. So you'll get a straight line. Okay, in case of, so hence D, option D, moving with uniform acceleration, would be this one. If it was uniform deceleration, it would be this one. So in non-uniform motion, either this could be possible, or the other possibility for non-uniform acceleration, what could be the velocity time graph like? So this is time, and this is velocity. So non-uniform acceleration could be like that. Okay, a curve or like that, right? So this is a case of non-uniform acceleration. So we saw in this video a velocity time graph for different scenarios. So whether it is uniform velocity, which will be looking like that. If it is at rest, it will be like that. If it is non-uniform motion, there could be two possibilities: uniform acceleration, non-uniform acceleration. So uniform acceleration will be like a straight line in a VT graph, right? Straight line but not parallel, and not parallel to the time axis. And a non-uniform acceleration would look like this.